Hello, welcome back to another math video. Today we're going to continue to deal with angles in standard position. We have now built the framework. We're going to look at angles of various sizes, not just the one we have been working with, but also reflex angles. Okay, and that is the Cartesian system. Today we're going to start doing a little bit of trigonometry. Okay, first we want to look at, this video aims to look at how we can transfer our Math 10 definition of trig, and in the next video we can actually bring them to specific angles and how we can actually calculate their trig ratios. And afterwards, I'll get some tips and tricks in actually remembering some special trig ratios for some special angles. Before we begin, you see a picture here, but our focus is actually right here, down in example 1. This is our Math 10 definition of trig. SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over hypotenuse. Okay, this is a definition we know. But we have moved beyond that framework now. Okay, we're moving beyond that framework. Okay, that's because we're now in a Cartesian system. Okay, we're in a Cartesian system which allow us to work with even more angles. So how do we translate this into the Cartesian system? Letters we will use is actually the x-coordinate, y-coordinate, and something called r. R stands for radius, actually. So consider this angle here, which is in standard position. I'm going to highlight it in blue so it stands out a little bit. Okay, this angle is in standard position. Okay, we don't know the value of the angle yet. Okay, we don't quite know the angle of the value yet. Okay, but how can we do trig about this? Well, we know there's a point on the terminal arm. Okay, the point on terminal arm is x, y. Okay, that's a point on the terminal arm. How can we find the trig value of this angle? You might think, oh, that's crazy. How can we do that? The more observant of you will notice I actually labeled the right angle triangle here already to help you solve. Remember, x and y is just the x-coordinate, or the distance from the distance you have traveled on the x-axis to get to the point. So this distance is just x. Same thing for y. So this distance is y. Then you immediately realize that y is just the opposite. X is actually the adjacent. Okay, x is the adjacent. Now we also need an analogy for r. R's radius. R is going to be the length of the terminal arm inside the triangle. R here. How can we find r? Well, that's easy. We can just use the Pythagorean theorem. Okay, Pythagorean theorem. R is equal to the square root of x squared plus y squared. Remember, the point itself is xy. We calculate r. So r is hypotenuse. And then now we have all the information needed to do trig in standard position. Okay, trig in standard position. So before sine was O and H, O is Y. Oh, this is a new definition of trig. Y and hypotenuse is R. Cosine is adjacent over hypotenuse, but adjacent is X. So it's X over R. And finally, tangent zeta is opposite over adjacent. Opposite is Y. Adjacent is x. This is the Math 20 definition, if you want. Okay, Math 20 definition of trigonometry. Okay, so we don't use this anymore. It's not wrong. This is a generalized version of that. Okay, we don't use this anymore. We use the new definition or the more general definition. It came from the old one from Math 10. Okay, it's not like the old one is wrong. It's just this one is more expensive. So how can we use it? Well, for instance, we have a point, -4,8, that lies on the terminal arm. Let me highlight this one. -4,8 is on the terminal arm, okay, of an angle. We want to draw the angle. Okay, it's on the side. But the key here is we want to calculate the exact values. Okay, calculate the exact values. So no rounding here. Okay, no decimals or rounding here of the primary trig ratios. Well, let's draw a picture first. Start. Remember, we're doing in standard position. We start with our Cartesian plane. I'm going to actually draw the Cartesian plane in black here and draw the angles in blue. The axis and angle is in blue. We'll draw the initial arm first. Okay, draw the initial arm first. Before I draw the terminal arm, I need to know where my terminal arm should be. Well, all we know is the point -4, 8 is on the terminal arm. So let's put down -4, 8. So x is -4, y is 8. So that's the point. So since it's on terminal arm, our terminal arm better pass through this point, like that. So our angle is from initial to here. That's my angle. Okay, that is my angle. You can even label. We didn't ask about reference angle, but maybe a good idea to label in the reference angle. I think we have been doing it in red. So our reference angle is right here. We don't know what it is. We do not actually need to know what it is because we're not being asked about it. Okay, so that's the reference angle. Okay, and that is it. Okay. We do not need the full right angle triangle to solve for it. We do not need the right angle triangle because, okay, we have generalized sine, cosine, and tangent using coordinates. Okay, using coordinates. All right. So sine of the angle is opposite over. Oh, wait a second. Not opposite and adjacent. Y over R. Okay, we'll fill in the numbers later. Cos of the angle is x over r. Tangent of the angle is equal to y over x. All right, y over x. Now let's see if we know everything. X is -4. That's the point. Y is, of course, 8. That's from the point -4, 8. This provides us with the information, but we do not know r. Now, r we need to find using Pythagorean theorem. R is the length of that arm. So r squared is equal to x squared plus y squared. R, of course, is equal to, I'm going to bring the square root over. R is always positive. Okay? R is always positive. So we take the positive square root. Okay, that's just the convention we use. Because, okay. So R is, of course, x is -4. Be careful, it's not 4. X is -4 squared. Y is 8 squared. Doesn't matter because it's square. You become positive anyway. But you need to recognize x is 4 because it is important when we calculate the trig ratios. 4 squared is 16. 8 squared is 64. We add them together, of course. We get 1080. Okay, we get 80. And then what we're going to do is 80, simplify this expression. 80, of course, is 16 times 5. Well, you may want to take some time to get that, but I'm just going to simplify it right away. Square root of 16 is 4, so it's 4 root 5. So R is 4 root 5. Remember, exact values. I do not want to see, when I say exact value anywhere in the question, I will not accept decimals, okay, rounded values, okay, or anything like that as an answer. Okay, I want the square roots, I want the pies and all that stuff kept in the equation. So R is equal to 4 square root of 5. Okay, remember in math 10 we learned how to operate with radicals, but I'm getting ahead of myself. Okay, so there it is. So now we know x, we know y, we know r is 4 root 5. Now we can calculate the trig ratios. Okay, sine theta is y over r, y is 8, r is 4 square root of 5. Don't forget, remember how to reduce while we even have radicals. Reducing is exactly the same. 1, 2, so 2 over root 5. That is sine of the angle. Remember, we do not even know the angle yet, but we can calculate it exactly just like we did earlier in Math 10. The only thing you change is definition changed. X, now be careful, x is negative 4 over 4 root 5. 4, negative 4 and 4 cancels. So we got negative, don't forget it's 1 over root 5. So that's the cosine of our angle. It's negative 1 over root 5. And finally, y is 8. X is negative 4. 8 over negative 4. Simplify that, we get negative 2. That's the tangent of our angle. Notice our sine, cosine, and tan ratios can now be negative. Trig values, there's no reason why trig values cannot be negative. Okay, so trig values can be negative in Math 20. Okay, trig values can be negative in Math 20. And often the case they will be. Often the case they will be. Okay. So with that, this is how you calculate the trig ratios of an angle in standard position if I give a point on its terminal arm. If I give you a point on its terminal arm. Now notice, I did label the reference angle in here. And of course, reference angle lies in the right angle triangle. Right? Lies in the right angle triangle. So, can you relate the trig ratios here with this right angle triangle here? Okay, I'll let you think about it while we do another example. Okay, there is a relation, but I don't want to quite reveal it yet. We'll do another example first. All right, but to summarize, okay, to find the ratio on a terminal arm of an angle, right? Find the ratio point. Okay, first, draw the point and draw the angle. That's where you always start. Okay, in standard position, of course. And then draw the reference angle, just it's a reference. It's going to be useful. Okay, draw the reference angle using terminal arms and x-axis. All right, and then you proceed to determine the exact value length of any missing sides. Sometimes I might give you r, sometimes I may give you x and y. That's normally what most of the time I'll give you, but not always. I'll give you x and y, or maybe r, and you solve for the third missing side, and then use the exact trig ratios for each. Remember, using, of course, the new definition, sine is y over r, cos x over r, and tan is y over x. Okay, not SOHCAHTOA, the new one. Okay, but it came from SOHCAHTOA. Y is O, x is A, R is H. So if you remember SOHCAHTOA better, remember this as well. Might help you. Okay, might help you. So let's start. Let's do another example here. Okay, we know tangent of an angle is 4 over 3. Determine the exact value of the other trig ratios given this condition. Okay, given this condition, the angle is between 180 degrees and 270 degrees. First, let's start by drawing the angle. Once again, we'll draw it in blue. So that's the Cartesian plane. Okay, we know the angle is in which quadrant again? 180 and 270. 180 degrees 270 degrees right over here. So my angle must be in between these two. So it's, okay, I'll draw the initial arm. It's not too important actually, initial arm is the same. And terminal arm better be in quadrant 3. So that's my terminal arm. I'm going to draw it really long. Okay, so I'm going to draw the dots later. Okay, there we go. So that's my angle. Okay, I'm going to do a really small label right there. And then I'm going to label my reference angle red. And of course, I'm going to, okay, then I'm going to put the points on there. Now, let's draw a right angle triangle to help us. All right. How does right angle triangle help us? Well, we are given tangent is 4 over 3, right? What is tangent again? Well, tangent, which is 4 over 3. Tangent, by our definition, is not opposite over adjacent. It's y over x is 4 over 3. So if that's the case, x doesn't have to be 3, y doesn't have to be 4, but when x is 3, y has to be 4 because it satisfies ratio. If x equal to 3, y equals to 4, so you can assume this point, 3, 4, is on terminal arm, right? So x is 3, y is 4 is a reasonable assumption because that satisfies the ratio. Okay, so let's go. 3, 4, maybe, I shouldn't say is on terminal, maybe on terminal. May on terminal. So let's see. Okay, this must be the point. This is 3, 4. Wait a second. That doesn't make any sense. How can it be 3, 4? This is in quadrant 3. X is negative and y is negative. That's impossible. But it can't. It's in quadrant 3. Impossible. Huh. Is this question impossible? Or can we find another point that satisfies this ratio? So nope, doesn't work. 3, 4 doesn't work. We gotta erase it. Okay, we gotta erase it. Is there another point we should satisfy this property that can lie in quadrant 3? Okay, this is in quadrant 1. Both are positive. Okay, think about it for a bit. Okay, think about it for a bit. Is another pair of x and y satisfy the ratio that goes into quadrant 3? Okay, hopefully you thought about it. Coming back, another point you're probably thinking about is -3, -4, right? That also works, right? -4 over -3 is 4 over 3, so this works out, right? It goes here, then go back, it works. So, and that fits in quadrant 3 perfectly well. So it's -3, -4. Perfect. That point fits perfectly. Okay, that point fits perfectly into quadrant 3. Then we know, of course, x is -3, y is -4. R, we can use our same formula again to calculate Pythagorean. -3 squared plus -4 squared. Just because I already did this beforehand and memorized the special ratio of 3, 4, 5, R is equal to 5. Okay. Now we can find the rest. We already have tangent. Now we just need to find sine and cosine. So sine of the angle, of course, is y over r. Y is -4 over 5. Cosine of the angle is x over r, and x, of course, is -3. R is 5. So we have just found the trig ratios for this angle only knowing its tangent. This is very similar to before. Very similar to before in Math 10, where we know the tangent. We can deduce opposite and adjacent, find the hypotenuse, and then solve for the ratio. Okay, this is exactly the same. The only thing we changed is the numbers can be negative because now we're Cartesian systems and we change the labels. Okay, that's not a sign, it's just indicating. Okay, opposite to y, adjacent to x, h to r, and you have to pay attention to the sign of your operation now. All right, and that's how you find a trig ratio given a point on the terminal arm. Okay, point on terminal arm. But food for thought. Okay, same question here. I'm going to go to another page. Same question. I'm going to draw really big. Okay, of course you have your terminal arm here, right? You have the point here, green even, -3, -4. And remember, I labeled the reference angle here, and I draw a little right angle triangle here, right? I'm going to draw the complete triangle now. Temporarily suspend the new stuff we have learned. Okay, new stuff we have learned with y, x, and r. If this is a triangle given to you, how would you label the side of this triangle? Well, what I would do is this point's -3, -4, so the x is -3, y is -4, and we earlier calculated that r is x, y, and r is 5. Right? R is equal to 5. Now, if we label the triangle, this point to be x, this point to be y, this point to be r, now we have a red right angle triangle with this reference angle. How do you calculate the trig values of theta r? What's the sign of theta r? What's cos of theta r? Remember, keep track, be careful of the sign. That's the only thing you gotta always pay attention now that we learned it. What are those? Okay, think about it. Okay, we know the trig ratio for the actual angle. We calculate that already, right, in the last question. But what about the trig ratio of the reference angle? Okay, what about trig ratio of the reference angle? Okay, try it out, and this does tie into our next video. I'll not reveal the answer because the next lesson actually is the answer. So tune me back how to look at how to compare our trig ratios of our general angle to that of a reference angle, and how we can use that to help us find trig values of specific angles. And with that, thank you for watching. I will see you next time in the next video.